So let's do a problem on what we have learned so far about one-dimensional motion. We're just going to read it first and do part A, then we'll do part B and C afterwards. So I'm going to call this group work. This is normally what I do with you together. And so you want to be working with me when I ask a question, you want to be thinking about it and maybe even guessing your answer out loud. And then when I speak, you want to compare how right you were, okay? Okay, so a race car starting from rest accelerates at a constant rate of 5 meters per second squared. Part A, what is the velocity of the car after it has traveled 100 feet? And then we're given a conversion, 3.28 feet equals 1 meter, okay? So what do we have here? We have a constant acceleration, so we can use our kinematic equations, right? Remember the caveat that we applied, we always have to check for uniform or constant acceleration before we apply our kinematic equations. Next, we are given a certain distance of 100 feet, and we are asked what is the velocity at the end. Do we know the velocity at the start? Yes, we do, because it's starting from rest. So that means the initial velocity is 0. So we know one velocity, we need to find another velocity. We have a certain distance and an acceleration that we know. Okay, so we are looking for an equation that has all these 4 terms and has only one unknown, which will be the velocity, which is the final velocity. Okay, so I'm going to switch to a whiteboard. Let's see how easily I can do this. And let's make it full screen. How do we do that? So here's my whiteboard. We read the question. We have a car that moves a certain distance, right? So what's the first thing we should do? That's right, we're going to sketch a diagram. So I'm going to use this, and I'm going to sketch whatever it is I know. So let this dot here represent my car, okay? So it's a red car. And it starts from rest. It's going to move a certain distance in one direction because that's what we're dealing with. What do we know about the initial thing? We know its initial velocity is 0 at this point. Let me call that V0, okay? And let's say this distance here is 100 feet. So this is 100 feet. And we're going to have to convert that to meters, right? So we were given that 3.28 feet makes 1 meter. So if we divide by 3.28, our result should be in meters. And if you do this, you're going to get 30.5 meters. Okay, so this is my distance. So this is delta x. This is the change in x value. We're going to set this as our origin. So this, because x value 0, and this value of x is going to be this 30.5. We are asked to find the velocity at this point. I'm going to call this my final position. So V final. Okay, like, yeah. Okay, so now you're going to look at your kinematic equations to find a relationship containing Vf, V0, delta x, and what else do we know? We know the acceleration. The acceleration is a constant value of 5 meters per second squared. Okay. So if you look at your equations, we're going to choose one of them. And let's say we choose the one which is V squared minus V0 squared equals 2a delta x, right? So I chose this because this has all the terms that I've written here, okay? V being my Vf, okay? So you could have a little Vf here, you don't have to write it. I'm going to solve for Vf because that's what we want. So we have Vf, V final squared, equals, so we're going to take V0 to the other side. And V0 is just 0. So this whole term actually is going to go to 0. So I don't need to take it to the other side. V squared equals 2. I'm going to put in the value for A, which was 5, and the delta x, which is 30. So the key thing here was to not forget to convert. You need to be in MKS units for everything. So you have to convert from feet to meters. And if you take the square root of both sides, you should get the velocity to come out to be, let's see, 17.5 meters per second. Okay, so that's how you do the first part. Remember our problem solving strategy. You read the question, you make a diagram, sketch a diagram, you write everything that you know on the diagram, you write what you don't know on the diagram. The next step is to try to find a relationship linking what you don't know to the quantities that you do know. In our case, we chose from the kinematic equations because we found that they were applicable in the case where you have uniform velocity. And then solve for your unknown, which is VF. That means on the left-hand side, you need to have only VF. Then you can substitute in your values, use your calculator to get the final answer. Once you have your final answer, you want to look at it to make sense of it. The 17.5 seems a reasonable value. If he starts from 0 and accelerates at 5 meters per second squared, covers about 30 meters, it seems reasonable to me. You want to make sure that you have written units, which is meters per second, which is the unit of time. And then you have finished part A.